So they're going to be under announcements. That's for all of you. So if you miss a class or you want to go back and catch up on something, you know, again, go there. And Austin, next week's a holiday, right? Next Monday.
Yeah.
What
It's
holiday?
not-
think it's
I don't know,
Memorial
it's-
Day?
Yeah, Memorial Day. So it's so read the, so there's an assignment tonight that's for the fourth week after the holiday. So don't forget that. It's easy when there's a holiday to think there's nothing to do. Okay, so we're back. And so auditing's really critical for building performance, because you have to diagnose what's wrong with the house before you can repair it. Or if you're building a new house, before you can, you know, build it in the right way. So everybody gives audits. There's the energy company used to post on their Department of Energy website, do-it-yourself audits. They may still do it. And those are fine. You can get a lot out of those, and they're usually low-cost items. And then the utility companies started doing audits because it, you know, it affects the use of their power. And originally they wanted you to use a lot of power or gas because they made money. But then it became a problem when it was overloaded, you know, like air conditioning overloads in the summer. And then they started getting in trouble. We had that big fiasco in California where we ran out of energy and we bought it from neighboring states who charged us triple rates. And there was that big hubbub, remember? So so now they
What
want to make
happened
sure
with the no energy in California?
it
How do we
was I don't know, 5-6 years ago. It was a summer, I think, and it was too hot and everybody was using the air conditions, and we couldn't cover the power. So we have agreements with, every state has agreements with other states for extra power if they need it. But for some reason, our agreements, we'd never used them or something, and the rate they charged us was just exorbitant. It was way out of the norm. And so there was this big brawl between the state governments or the state utilities. So now it's, as temperatures get warmer, you saw what happened in, was it Houston? Where that got really cold recently.
Yeah, I think it was just throughout Texas.
Yeah, it was throughout Texas and Houston. They really had a lot of trouble, and they didn't have enough juice for the heater. So people froze, and, you know, it was pretty nasty. So the heating temperatures are going to just get higher, and perhaps the cold will get colder because of global warming. So utilities are really going to have to, but one of the things they do is they try to make the ratepayers more cognizant of how to save energy on their energy use, how they use their energy throughout the day. And they always come up with these programs to kind of reward people that don't use energy during the peak hours and this and that. They've got a lot of programs, and they have to do that to make it all work. So the Department of Energy and the utilities are really anxious to make this distribution of energy keep working. And here it doesn't matter. If we don't have energy for heat or cool in Santa Barbara, who cares, right? It's the same temperature all year practically. But in the colder climates or the hotter climates, you really suffer if you don't have those services. So there's do it yourself. And then did we talk about HERS raters, home energy rating system last week? I'm not sure if we did, but we have a whole unit on it later in the class. But oh yeah, we did talk about it, because we talked about performance, how the city building departments, you can either do a performance-based or I forget what the other one was called. So instead of just having the certain amount of insulation on the walls, the minimum requirement, you could have things that made up for that, not an insulation. Maybe you had a tighter house, so less of your air leaked, your warm air leaked, even though it wasn't as insulated. But here you go. They couldn't handle, the inspectors couldn't handle knowing all the new technology and stuff. They have enough to handle just with regular building knowledge. So they decided, so there, a couple of nonprofits came up in California and they started training. They started creating training programs to train people on these new technologies and building performance diagnostic tools and stuff. And the biggest one, there were two companies and they sponsored this program called Home Energy Rating System, HERS. And their auditors were called HERS raters because they went out and rated, not rated like you'd rate someone's house, but rating like you'd rate someone's house. So these HERS raters, that became the biggest program to do that. And they're so big and things, and because the government's making houses having to be tighter, they're making the specifications on tightness and insulation more. As you know, the Green Building Code keeps getting more stringent. Now we really need auxiliary inspectors and people to audit homes, but also if homes are using these things, they have to go along with the building and make periodic appearances at the building site and make sure they're being done right. Sometimes you can get them done and you don't see that they're done wrong, and you won't know until it's too late, and you may have to tear out some machinery or stuff. So now they do a lot of the inspections along the way, these HERS raters. So it's becoming a part of standard building now. It's no longer something a few people do. So the HERS raters also inspect. So they'll go into a house and they'll inspect, like say you want to improve the performance of an existing house through retrofitting. They'll go in and they'll look at all the issues and problems you might have, and then they'll tell you what you could do to make it better. And then if you go with them, they'll inspect all along the way. They don't do the actual work, but they'll inspect along the way and make sure that your house is turning out the way they advised that you could get better performance. So they also, so HERS raters have their own energy audit, and we're going to look at a video of that at the end today. And then all kinds of companies, Energy Star, different programs have auditing programs, and we'll look at a couple of brief ones of those, and then we'll talk about the stuff in the. We'll go quickly. It's not the most interesting stuff unless you're wanting to get a career in this area. And later on in the course, we have a unit about making this kind of thing a career. There's a lot of good videos on it. And, you know, in the past, like 5 years ago when well, maybe more than that, 8 years ago when I started these programs, Santa Barbara, the weather was so good that there wasn't a lot of changes people would do to make their homes more efficient. And so it was really hard for a person to make a living advising people or auditing people, you know, or inspecting people to make their houses, you know, perform better. So I would tell students, well, any year now it's going to break and we're going to need a lot more of these, and they would keep going where they didn't do it. But in that meantime, in the last 6 years, the government's really cracked down. And now energy efficiency is becoming a huge thing because of global warming. We're kind of against the wall and we've got to do this stuff faster than we thought. So it's no longer a casual thing. And the building departments are really starting to crank into this. And so we're going to need a lot more of these kind of inspections. So now it's a more viable career. So we'll talk about it later in the course because, you know, some of you may not want to be actual builders out in the field, you know, framers or finish people. I hope some of you are because we still need those. But some of you who actually may have more of a background in computer and software might want to hook into these auditing programs and become auditors. It's just another direction in the building industry. Okay, so let me set up these. Yeah, question, Jack?
Yeah, if you're doing a remodel and it's not anything structural and you're just taking off siding and like putting it back on, and you're not really like breaking down headers and studs and beams and all that,
Yeah.
But you expose the framing, are you supposed to like cover it up with insulation, or if there wasn't any in place?
There's a percentage of the square footage of the house. If you're below that percentage, it's a small percentage, but if it's a small area, If you're below that, you don't have to do anything. Just patch it up. If you're above that, if it's above that percentage of the whole floor, then they'll make you bring it up to present requirements.
Right, because I'm doing this one garage, and like we opened up like maybe a quarter of the garage, and then
Yeah.
like we're gonna put in insulation, but I thought it didn't make any sense because it's gonna like get hot and cold literally everywhere else except for like this small little section. But that was kind of
Yeah.
dumb.
Yeah, well, that's not a bad point of view. Sometimes when the whole rest of the building's not insulated or, insulated to a certain extent, you don't want to go way over that. You're right, it's just ridiculous.
Yeah,
Yeah, if you're not getting a permit, they probably want you to put some in, but I think the way you're thinking about it is right. It's not a critical thing, especially in a garage.
yeah,
But then again, people are converting garages to additional dwelling units, right?
yeah. ADUs.
Yeah. And so you want the people that live in there to be comfortable. So if there's like, I'm helping a friend design a garage. They're turning it not just for their own kids. They're turning it into a room.
Yeah, a lot of
Getting rid
the
of
construction on slab on grades, they'll
Yeah.
hide like sewer lines and power lines and all that, and then
Yeah.
they'll just use quarter-inch concrete like float over it. And then as soon as you get your final inspection, you go in there and you expose it and you break it out for the ADUs and stuff.
Yeah.
I do
Yeah.
like
Well,
that.
people have always done that in Santa Barbara, and now, I mean, at least they okay them now. You may not want to go through all the requirements they have, but it's a step in the right direction because, I've always thought people should be able to do what they want. The reason they were so against ADUs in garages was because parking is such a premium, and they were always upset. They were always obsessive about having enough parking in residential areas. But people figure out how to park. Look at New York. There's no parking at all, and everybody figures out how to do it. It's just what you do. But I was helping a friend remodel, and we wanted to take some area out of the garage for something. I can't remember what it was now, but they barely had enough room for 2 cars to park in their garage. And what I wanted to do would take a little off, and you could only park 1. But they had a driveway. They never parked their cars in their garage anyway, and they had a driveway that had 2 car slots in it. So it was such a hassle. I mean, it was downtown, and the city was just anal about, oh, you have to keep that garage clear, So it gets crazy.
Everyone
Okay,
just
so
fire lanes
yeah.
around here.
What's that?
Everyone just parks in the fire lanes around here.
I know. But I lived back east for a while, and everybody double parks, especially New England. It's just kind of a way of life. And whenever I do it here, like I say, I'm just going in for a second. I just got to drop this off. My wife goes nuts. She can't stand it when I double park. And actually, you can get ticketed here. It's less easy, but the residential is easier because the cops aren't around. Downtown, there's a lot of police, and they'll get you for double parking. But okay, so let me go to okay, so does everybody see this YouTube? What's my first film here? How to perform. There it is. Okay.
Yes.
Welcome to the Amazon Fulfillment Center tour. We're really excited to be showing you around our building.
Yeah, well, we're not excited to see it, so.
Got a fairly modern house, a little less than 10 years old.
So I gotta warn you, since this is one of our first videos, I'm gonna stop and start it here and there if a point needs to be further explained, okay? Or you can actually ask questions too if something's really not clear to you. Is the sound okay? Let me know if the sound's okay on this.
Fully insulated house, good quality windows, insulated doors.
Can you hear that
Homeowner's
okay?
Got a little bit of an office space over the garage.
Sounds good.
Notice we got the
Okay.
fully
Yeah.
continuous soffit venting up above.
Where do you start your audits?
Best bet is start right inside. It's helpful for us to speak with the homeowner in advance, and we spoke with the homeowner here about some of the issues in the house.
Which were?
Very cold house, a lot of drafts.
See, we're gonna talk about the audit in detail. He said they talked to the homeowner ahead of time. So we're gonna talk about ways that they do that.
Extremely
The
cold.
reading said to start on the outside and go in. This guy's saying to go right in.
Not surprisingly, high heat bill.
Yeah, hold on, let me pause this. Yeah, did you see where this was?
Yeah, it's cold outside. It's not.
It's Massachusetts, but they should do that. And most of the ones now, these films, the oldest one is 10 years old. I try to get ones that are just 1 or 2 years old. But I got to tell you, the audits change quite a bit from region to region and from time to time. Like if a town has more stringent sustainability requirements, then they'll require more. But looking at the outside, Louis, I was telling you that whole thing was fashioned on Building Performance Institute. And when we get into that, you'll see it in even more detail. So good point though. Yeah, there's a lot on the outside you should look at. This is a very narrow energy audit, and BPI and the book that we have, the audits are larger in scope. They include safety because there's a lot of things in houses that are unsafe. And even though they're doing energy audits primarily, they don't want people to get sick or have problems health-wise. So the audit's a little broader. We'll talk more about that.
Very often.
Well, very typical complaint.
It's a fully insulated house, though, so how do you kind of get to the root of the problem?
Luckily, we've got the diagnostic equipment, such as this infrared thermal camera.
Right, so we've got
Yeah.
a monitor here. Can I plug it in and have a look?
If you would. Plug this in, I'll show you exactly how we can
let's-
utilize this.
Take a look at the house and see what we've got. So if it's taking pictures of temperature, what is hot, what is cold?
Well, for example, we'll start on this window. You can see cold is represented by black.
so this big black patch right there, that's all cold.
Low temperature, as opposed to, of course, the warmth of my hand.
Oh yeah, nice bright
So,
and white. All right.
Fairly straightforward, very easy to interpret. Now you can see as I pan over the studding, the wood studding.
So the vertical lines, the darker lines here represent the studs, and in between it is whiter, so that's warmer.
Look at that
because of
corner.
insulation.
Wow.
The insulation has a higher R value than the adjacent studs.
So let's start the audit.
Well, I've been through the whole first floor. I think we should go upstairs to find out what's going on.
So around the corners there, it gets a little dark, and you think that's because that what is fiberglass insulation pulled away?
Could be. You need good contact with the ceiling board to get that good thermal performance.
It's a lot of dark around the perimeter. What's going on here?
The closer we get to the eave, the more substantial the heat loss is.
Boy, that is really dark.
This is ice cold here, Kevin, almost as if it were totally uninsulated.
We've got ourselves a serious problem in the attic, don't we?
We've got to get up there and check that out. Another place we always want to check for drafts, Kevin, and heat loss is interior partitions.
Interior walls. I thought
That's
we were looking
right.
for drafts, though.
Well, let me show you some interior shots with a scanner. Here we are, a heated partition between the bathroom and heated bedroom beyond.
So heated space on either side of this wall, and what are we looking at?
Well, you can readily see cold air between the studs here, represented in black.
So the studs here are white, and then the space in between, which is darker, is cold?
Full of cold air. Somehow this interior partition is connected to the cold attic above. Sometimes these interior partitions can almost act as a chimney or a conduit. Warm air goes through the sheetrock into the uninsulated wall and is carried, warm air rises right up into the attic.
So that's another draft. How do we tackle that problem?
We're gonna have to go up in the attic to see the detail. Take off dust mask.
Okay, always a good thing to be using when we are working around insulation and
Right.
some gloves as well.
Exactly.
So you've got some air leaks to show me?
Right. If you recall, we were downstairs for one of the big air leaks we saw was inside the bathroom partition.
That's right. You actually said the air was moving through the wall.
Right. Let's look down below here. We're right over that partition.
Oh my, look at
And here we
the
are.
size of that opening.
Right. Right. You can actually feel the warmth rising up.
It's like a giant chimney running through the center of the house.
It's a heat loss conduit dumping warm air right into the attic.
And you're telling me that I can feel that.
Right. Is there any wonder their heat bill's so high? Okay, one of the first steps I want to do is just create a little bit of a backer, just using some random unfaced fiberglass material. This just works as a temporary stop.
So this is not the air barrier.
This is definitely not the air barrier, because we know that fiberglass by itself will not stop air movement. With our fiberglass backer now in place, I can seal this with the foam. Let me show you how this works.
And it expands as it's applied.
Right. It takes about 20 seconds to really cure, but it's a fairly rapid.
And then so once this sets up, that's going to make an airtight barrier that'll stop this chimney or stack effect?
That's exactly right, Kevin. Then at that point, we're going to put our fiberglass back down. The fiberglass will now do a good job because it's in an airtight configuration.
So Bruce, a lot of these holes that we found and have plugged are sort of in the center of this attic area or the
Right.
ceiling below. But when we looked at that thermal image a little earlier on, all the dark black spots were around
right.
the edges here. So I think that's where the heat loss is coming
Well,
from.
we also had heat loss out near the eave area. Let me show you what's driving that particular problem. One, the insulation vat doesn't always go all the way out to where it should.
So there's a gap, and that's just 0 R value.
Exactly. Number two, the particular type of vent chute used does little to block cold air from actually getting underneath our fiberglass bat and cooling down the bedroom ceiling below. Let me show you a little better solution to that allows for the ventilation. This is a corrugated cardboard chute made just for that purpose. Fits right into the 16-inch on center framing.
Mm-hmm. And then you just sort of staple it to the side.
Fasten that, but it also has this vertical component to it. And what that does, it blocks that and diverts that soffit air on top of the fiberglass.
So the air is still allowed to come up through the soffit, but instead of coming this way underneath the fiberglass or through the fiberglass, it's actually blocked and diverted up into the rafter bay where it is supposed to be.
Right. Very simple solution.
And then you just put that in the rafter bays all the way around. Okay.
That's right. Then we can push our fiberglass all the way out to where it should be.
If you
So one more short one here. It's going to be a do-yourself.
We had a frost last night and it's starting to get cool, so you might be thinking about how you can button up your house
Hey, she's got the greatest Maine accent. I want you to listen to it.
and save some energy this year. One thing you want to do when you're thinking about that is to have an audit done or do a self-audit yourself. How can you tell which one you need? Well, if you're applying for rebates or loans or things like that, you may need a professional audit done. And in that case, you'll need to call and line up someone to come do that. While you're waiting for a professional audit, or if you choose not to have one and just do it yourself, you can do a self-audit. You can get a little checklist like this that we have, and it will give you ideas of things to look at around your house and find ways to go around and find those leaks and penetrations that can make a big difference in your heating bill. As you're walking around doing your self-audit, you're going to look for joints and penetrations where air might be leaking in. You'll be looking for insulation and how much you have and how much more you might need. You'll also be looking for places where you might caulk. You'll be looking for the quality of your doors and windows, the types you have, whether they're well caulked around them or whether they're allowing air to leak in. You'll also be looking at things like your appliances inside and seeing whether those may need to be updated. There are a lot of things that anybody can do. There are low-cost changes you can make, moderate cost changes, and high-cost changes. The audit will help you go through all those things and then make a decision on what you need to do and what you should try to do first. So check around the outside of your house, around the foundation, and look for cracks and leaks. Anything that opens from the outside to the inside could potentially have a place where air could get into the house, cold air could get in. So check for those, make sure they're filled in, they're sealed, and they're tight. As part of your energy self-audit, when you walk around your house, you want to check your doors and windows to see if they're drafting. You can make your own low-cost draft checker by taking a used feather out of your down vest if you have one, or milkweed pods if you get the seeds from those. Or you can get a pencil and use some double-sided tape and attach some little toilet paper strips to it. What you want to do is hold that up against the window when it gets colder and see if you have motion. If the strips or if the feather is being pulled toward the window and out, then you have a draft there. You're losing a lot of heat and you need to do something about that window.
So, yeah, you know, most of the audit things are from the north and northeast. So we got a Maine and a, hey, Alec. So we got a Maine and a Massachusetts version. That wall, did you see it didn't even have a top plate, that wall that they were looking at from the attic? It looked like they maybe nailed it to the, there may have been a joist coming in there. They just nailed it to the joist, the studs to the joist. But yeah, there's a lot of, in old houses in Santa Barbara, there's a lot of bungalows and Victorian houses that are fairly old, 100 years, 150 years sometimes. And they have construction like that, really. What's the opposite of platform framing? The full length?
Balloon framing?
Balloon framing, thanks. A lot of
Yeah.
balloon framing in those old places, and they are notorious leakers because of the way they build. There's just no, so you got to go up in the attic and just fill all kinds of holes. We'll look at all that. We got a whole unit on diagnosing the holes, and then we have a whole unit on filling the holes. So we don't need to get into details on this one. It's funny, those these audit films, they just got into a lot of detail, but only a few areas, and then they ended it. It's kind of weird, but.
Do you know the R value of a standard 2x4 dug first ed?
What is the R value?
Yeah, like what's the heat transfer like on that guy?
I don't know. Does anybody know that? Next week, no, the fourth week after next, we're doing insulation. And on your handouts in your module shell under assignment that you're going to read, I have page after page of what is it? R 2x4 is what? R. It's not up to R19 now, is it? Still probably R13.
No, I'm asking like what the actual R value of the wood itself is.
Okay. What were you asking?
Is like what's the R value of the wood itself, like the actual stud?
Oh, the wood, the stud. Oh, okay, that I don't know offhand. That's in there too. It's got insulation values, and then there's another sheet that's got, you know, concrete and per inch and wood, hardwood and softwood. So yeah, we'll go over all that the fourth week after next. That whole night's devoted to that. That's a good question. It's good to know. You know, you might have got the question, Jack, from looking at that wall in the bathroom, where normally the studs are dark and the in-between's white. And here it was, the studs were white. And I've never seen studs that white before. So that meant that the heat was going through the studs, okay. Which is, usually it's slow, but when it's inside, it just stays there because it's not, the heat's the same on both sides, so it doesn't have anywhere to go. So it kind of stays in the wood. That kind of made me think too, that particular picture they showed.
Yeah. Usually the opposite, where like it's more well insulated in between them.
Yeah. Yeah. We'll talk a lot about that because, you know, we've talked about in insulation, putting in pretty good insulation between the studs, but also putting insulation on the outside, like rigid insulation, because of the thermal bridging through the studs. As they squeeze the houses for every bit of insulation capacity, now they're starting to look at studs and saying it's really important now. And we have this passive house movement, which is coming, and it's kind of Germany's early on sustainability approach. It's really great. We're using it more now. And it almost always has outside insulation covering that thermal bridge of the studs. So we're considering, you know, at first, you know, it goes in increments, right? At first people start thinking about it and then they go, okay, we need better insulation. We need to do the insulation better. Now we're looking at the studs. Now we don't want any thermal bridges. And it's just going to keep going because we're squeezing we're making places as tight as we can because of this global warming. We
Is it
can't
gonna-
afford.
Like first strips.
What's that?
Is it going to be like first strips on the studs, or is it going to be like a sheeting sort of deal?
No, they're coming out with new products. I mean, before you just put, usually you'd put the insulation, the rigid right up against the plywood, the sheathing.
Yeah.
And then you'd put stuff right on the insulation. Then they started saying for draining, for water drainage, like with rain, you want to put strips on top of the insulation and then the siding on top of those strips. So that's another revolution, is making it waterproof. That's come up. So yeah, but now they're actually making products that are combination insulation and plywood. So instead of sheathing, you just put these one piece on. And I just saw something in a video I was looking at. Whenever I go to select videos for you guys, I look at 10 of them next to it because there's so many new products and new things. It's really, you could spend hours on that, and I try to limit it. But one of the things they showed was a new piece of sheathing insulation combination that also had air barrier involved. It was really tight. So you put that on, you get an air barrier as well. So that's kind of the way they're going now. It's easier for construction companies if they just buy this one product and put it on. I don't know. We'd have to look at how they tape those because the joints are still problematic in terms of air leakage. But I think they probably have tape, that special tape that goes with that. Yeah, it's pretty. It's getting pretty intricate. Okay, so let's go over the handouts and ask lots of questions like Jack does, because it'll keep you awake. This stuff, auditing is not the most fun stuff, but it'll give you an idea of what kinds of things you're looking for and how to quantify them. They have software programs that if people have their own, if people are auditing professionally or for another large company or for a energy company, they'll have software programs and they'll do it all through those programs. And Mike Ganella and I, Lewis, when we first did the audit class, we got a grant to make our own software. So we got together with this software company. Oh boy. And it wasn't the right company. They kind of didn't know what they were doing, but we would go meet downtown with them and we'd give them all the data that we had, all the categories and all the data, and we'd tell them what we wanted on the software. And you should ask Mike about it. They never did come up with a satisfactory product, but it was really.
Pay him?
Huh?
Did you pay him?
I'm not sure. We might have paid him a little bit. But we learned a lot about what's involved with that, and neither of us knew a lot about programming. So when they try to explain stuff, they just have a whole program face, and we go, oh yeah, right. We definitely understand that, But
How long ago was that?
It's quite a ways ago, 6-7 years ago. We were trying to, they just had energy audits, and I wanted to do a sustainability audit that was bigger. So I wanted to do water, and I wanted to do clean air, and I wanted to do resources, and I wanted to expand the energy to those other categories. So there wasn't one out. So we just took all the dimensions and categories and data and fed it into this, and nothing ever eventually came of it, unfortunately. It wasn't, we weren't trying to, if you really were serious, you'd want to do it for a product and make money from it. We weren't serious in that vein. We just wanted to see if we could get one going to show people. There was a guy, some of you may have heard of or even know. He does the gray water instruction. Art Ludwig, anybody know him? Is anybody in my class? I think it's the green building. So a lot of you haven't taken that because you're waiting for next semester. But Austin, did you take the green building class already? Yeah, so you saw his thing on yeah. So he's a local guy. He lives up in Trout Club, which is on old 154, almost to the top of new 154. And in his house, he's done a lot of sustainability stuff, and he came up with an audit, and it was like a hippie audit, you know. And I say that having been a hippie part of my life. It was a lifestyle audit. It was what's valuable to you in life, you know, saving energy, helping the global environment. This was way before global warming was a huge issue. And it was actually really a great thing, but it was like a 5-page audit. And it would eventually get down to energy and water and everything, but it had a lot of stuff like, well, you know, what do you like to do? Do you like to read at night or watch TV? Because he wanted to know about what kind of lighting you needed, you know, and you know, outdoor lighting you might want. That was fun. I usually give it to the class. If I can find an old copy of it, I'll paste it for you guys. It's pretty fun. People treat him kind of like a nutcase, but he's just really into what he does. And he and a person that worked for the Santa Barbara City and their water program went to Sacramento and lobbying them into allowing gray water, laundry to gray water only, not sinks or bathtubs, only laundry. He lobbied and they got the state government to approve that using laundry to garden without needing a permit, which is phenomenal. If you ever want something to happen, get it out of the permit process because people don't want to get involved in that. So you can now have your laundry empty into your garden and you don't need to take it into the sewer. You know, there's precautions you have to have. You can't use soap that's going to wreck the environment, but it's easy to get the right kind of soap. And then he has a video that tells you step by step how to install the whole thing, what tools to use, what products. He sells some of the products. It's really a great effort. I mean, you know, he's kind of a home engineer type, but he got this going for the state, so you can't knock that. We need to do gray water for the whole house. That's really the next thing, and solar hot water. You know, you can just predict where we're going to go. And I've been, you know, trying to get these things going for years, especially solar hot water. You know, gas hot water is cheaper than electrical hot water, and we're going electrical, right? So for a while there, I said, well, solar hot water is the solution because it's free. And, you know, after you get your unit up, and it's neither gas or electric, so it's not contributing to greenhouse. But then they just came out with, last few years, they've come out with a heat pump electric hot water heater. So it's really efficient, much more efficient than the old one. So, you know, people probably go with that and still skip the hot water panels on their roof. But
You have to beef up the reframing for that.
What's that?
You have to beef up the reframing for the extra weight.
Great question. Possibly not. Depends on how old the house is. You know, this is water, right? So it's not like electrical panels, which are a little bit lighter. They're heavy enough, but these have actual tubes of water. But the good news is you only need 1 or 2 modules. You don't need a whole roof full. A couple of modules will provide all the hot water you need. So unless you have a really decrepit roof from, you know, an really old house, usually you don't need to. But there's an old guy, 80-year-old guy up above Wake Center. I used to take my classes up, visit his house, and he had one 4x8 hot water. He had electrical solar also, but he had a hot water array. And he said he had enough hot water all year for he and his wife to take showers. Not exorbitant showers, you know, they had to be fairly thrifty about it, but that did it for them. It was pretty impressive, you know. They're easy to do. It's standard plumbing that we've known forever. So, you know, the rest of the world has solar hot water everywhere you go. China, Greece, Europe, the houses all have they have the tank and the panel together. So we just didn't go that route. But we're going to be scrambling for various things the next few years. So let's go to Ta, 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 ta. Okay, you can all see that, right? Yes?
Sure can.
Okay, great. Okay, now on yours, you guys look at this stuff. I mean, hopefully, you may not have had time, but those of you who read this for tonight, on your Canvas page, were you able to enlarge it the way it was put on your page? Did anybody notice that?
I tried to, but
Zoom it.
But it wouldn't, right?
yeah, I wasn't very successful in that attempt.
Yeah. So if you know, most of you are young and have pretty good eyes. If you can read it, then we'll just go. But if it becomes a problem, I can take these, the ones I have, these handouts that I used for the Canvas, and I can send these to you directly, and then these will enlarge. That's why I'm not using the Canvas. I'm using the original one because I can enlarge mine. So just let me know if the reading becomes a real hassle. So what is an energy audit? We can cut through some of this. So this is purposes of an audit. This is interesting because you think energy, the word energy means, well, we're just going to see how much energy is being used and wasted, and that's it. But look at these other purposes here. Well, encourage behavioral changes that reduce energy waste. So that's still energy waste, but it's not the house. This is the people in the house. So one of the things all these programs do, any kind of auditor will do, is tell you simple behavioral changes you can make as residents to cut down your energy. So that's a really good thing. It's an educational part of it. Inspect the building and its mechanical systems to gather information necessary. So that's pretty obvious. We have to do that to look for energy problems. Looking at current energy consumption. And so most of these audits deal with your energy bills. They'll look at your bills and they'll find out, you know, what kind of energy you're using. Because you can't tell just from, you know, anecdotal evidence. You really need to see how much energy you're paying for over the year.
Can you put like a meter or something on your fuse box or like your breaker box so you know like what rooms use more, stuff like that?
Gosh, I don't know. That's a great question. I don't know if they have a smart meter like that. I mean, I just don't know. They could very well.
Because then you could tell where you're using your electricity at.
Yeah, but you know, it's the but Jack, if you think about how the electricity goes into the house and goes into circuits, it's all mixed up. It's all mixed up. You know, you could probably build the house so that the circuits were really kept separate, right?
Uh-huh.
And you could probably build it so you could monitor that, but it's going to be hard the way it is. But you know, that's not a bad idea.
Right.
Because then people would know where the use was a problem, you know?
Or like if
That's
if it's like a multiple dwelling, like if there's an ADU,
yeah,
could you tell,
yeah.
you could tell like what tenant is using more or whatever.
Right, exactly. Now, that's a great idea. You know, I'll look into that. I've never heard of anybody, you know, electricians are like everyone else. They don't like to change their routine. So, and you'd probably pay more, but you know, I wouldn't be surprised if someone's trying to do that.
Would you just have to split it from the street when it comes from the street? You just split it there.
Yeah, it'd be great, huh?
Then it's just like two things, though. I'm talking about just like one property thing.
Yeah, no, that's a good idea. I mean, I think they separate renters and owners and stuff. I think they know how to do that because that's been with us a long time.
Right.
People need to know if their renters are using tons of energy. But area by area, or well, we'll see how they break down energy in a minute, and it could attach to some of those like baseline energy or seasonal energy. Diagnose energies of energy waste, and notice they add health and safety or durability problems. So these are green issues that are besides energy, but they've somehow been included. And I think Building Performance Institute, and I took their training and I've got a lot of their literature. I think they maybe just decided to do this and everybody's followed. It's not bad because you don't want, you know, what their philosophy is, once you're in the building and you're doing this work for the client, why not, if you see obvious structural dangers or electrical dangers or health problems, why not tell them while you're there? You know, it'll make the audit more valuable. So recommend energy conservation retrofits. Yeah, that's obvious. Project savings. So a lot of software, you know, will allow them to project what the client might save by these retrofits, which is pretty important for clients to know. Estimate the labor and material costs for retrofits. That's more difficult because different companies charge different things, but you could have a span or an average for that. Note current and potential health and safety problems and how they may be affected by proposed changes. So when you're when you're saving energy, you're basically buttoning up the house, right? You're making it more airtight. And the law requires you to have minimum air exchange in your house so you don't get sick from toxins and humidity and stuff. And so when you tighten it up and you've got a lot of crappy things like cheap furniture with formaldehyde in it, or, oh, God knows, there's a million things, or you just store your paint solvents in the kitchen under the sink, or so all those things will be more of a problem when your house is tight because the air's not exchanging as much. So in some ways, tightening a house makes the health issue worse. But what you want to do is not keep from tightening the house. You want to go ahead and tighten the house to save you energy, but you want to deal with the health things. And there's a whole bunch of ways you can deal with that too. So yeah, they do. It's kind of a step-by-step process. You make one thing good and make something else bad. So you have to go correct that. But all this stuff's really understood. So it's pretty straightforward. And educate the homeowner about use and conservation, sure. And provide a record of the energy audit. Yeah, so, you know, people did it themselves. You can get software programs that will print out, you know, they have nice printouts of everything you want to say and it looks more professional. So the process, they're just saying there's different kinds of process. We saw the self audit, that's the minimal process. You can get an audit that's just a little bit more than that, like the guy maybe coming through that we saw on this old house video we just looked at. Or you can, you know, like the HERS rating guys, they'll do a really thorough audit. They understand this stuff pretty well. And of course they cost. The do-it-yourself is obviously free. And as you go up, they become more expensive. So it all depends on what you're using it for. If you're doing a new house and you really want to not only satisfy the code, which is tricky, there's a lot to that, but you want to really max out while you're building the house and be as comfortable and as healthy as you can and do your bit for the planet, then you're going to want someone who really knows all the angles, like a HERS rater, to come in and help you design the parts of the house. Screenings. They say there's the process here on the page before. It says visual inspection is the first part, diagnostic testing the second, numerical analysis the third, and then they say immediately screening is also an important energy audit function. So actually there's really four. So I wrote a 6-part one down here when I was thinking about it one time, but it's not important. But you know, if you're trying to make money, if you've got your own business or you're working for a company that's got this figured out, you don't want to spend a lot of time yakking with the homeowners. You want their advice and their feedback on what's uncomfortable in the house and what's costing money and where there's obvious leaks. They know a lot about their house. So you definitely want to ask them questions, but a good way to do it is to send them an online or a mail audit, and we're going to look at some of those. And they can just check things off and send it back to you. And then you can actually mold your survey, your on-site inspection and survey around those problems and make those problems the focus and maybe do some general stuff around those. But that'll save you a lot of time. You're not just going there cold and going through the whole house. You're actually getting important feedback from the owners. So this screening is really, I think, really a critical thing.
Hey, Patrick,
Yes.
we just see your folder open with all the thumbnails of all your different files. I'm not sure if that's what you're
Oh, really?
trying to show us or not.
No. Really, you just see the whole folder?
Yeah, we just see the folder with the different thumbnails.
Okay, well, we're gonna have to do it differently then. Hold on.
No worries.
Oh, I thought you were letting them know so they wouldn't get embarrassed.
Yeah, well, you know, you guys should tell me. I'm into the third or fourth page.
I thought you just had really good eyes.
Okay, hold on. So I just open it up on my screen and take them out. Here it is. No, this is it. Oh, damn. Oh, there's a lot of these. I can see why it took you guys so long to read these. It's a joke, right? Almost there. You can't see me doing this, can you?
No, we can't.
No, we just see your face.
Oh, good. Yeah, this is one of the things I have the most problem with is getting any handouts in a place where I can enlarge them and go through them like a slideshow. Sometimes you get a slideshow set up and then you can't enlarge them. So there's let's see. No. Huh. You know what I need to do is, well, you'll get it next week, is put these all together, you know, scan them. My wife's got a printer that can scan them all together. And then when you put them up here, then you can slideshow them. These I'm gonna have to go one by one. So I'll skip the first bunch. Oh, maybe this will go. So see this page 16 and 17 here?
Yeah, we can see it.
Okay, so I read through this list this was the list of purposes. And then I read through this summary of the process: visual inspection, diagnostic testing, numerical analysis, and then they threw in screening. And then I made a little more thorough process down here. But so screening, you can read this and it'll tell you about screening. But it's really good to get that information. It limits your time with the customers. It's really easy to get chummy with the customers and start talking about everything, right? And then the cost of your audit is you're losing money on the audit as you talk. Can you see this page now? Inspecting dweller interior.
Yeah.
Yeah, it switched.
Okay, but that's not the right page, so. Here's the next page. Okay. So then the inspection. We're just going to go through this briefly because, like I said, the BPI inspections more thorough and more detail. And we'll get that later in the course when we look at some of these organizations that do this stuff. But they started looking at the building exterior. Part of the problem is what can be on the what can you see on the exterior that would affect your energy use in a house?
Holes in the walls.
Yeah, holes in the walls, holes in the roof. What about cracks in the foundation? What about yard that's not sloping away from the foundation? What problem would that cause?
Drainage issues.
Yeah, and if it doesn't drain, but it goes maybe actually into the basement or crawl space, what might that do?
Mold.
Yeah, so that's not an energy issue, but it's going to be a health issue. So because they're also doing health, they look for those things on the, you look on the outside, go all around the perimeter of the house and make sure it's looks like it's draining okay. There's all kinds of things you want to identify with the house. Porches and attics that may have knee walls, like this looks like it has a knee wall. You can see that from the outside, and those have a lot of leakage issues. So you just make a mental note or jot it down, check the attic knee wall area, check a porch area. So all that stuff you can see from the outside. You can also identify vents, where vents come out on the roof and vents on the walls, and make a note of those because those can be problems too. And of course, windows. You should look at the windows from the outside and then you'll go back and look at them again, but a lot of leakage in windows. So you would look at that, and then you'd look at the interior, and we'll, just like that guy did in the videos we saw, and we'll go more into that because we're going to look at all the places where leaks occur in the next coming units. What's that?
You know how caulking prevents like the airflow and stuff?
Yes.
If you caulk the bottom of a window or a door, doesn't the water get trapped behind it because it can't come down? Like if you like caulk the bottom of trim.
Yes. You shouldn't caulk the bottom, right?
Is there a way to caulk it without having the water get stuck?
No, because if you put, like most people put like flex tape or straight tape, on like say you have a fin window, it's got fins on it. You nail it, and then you put that over the fins. That keeps water pretty much out and will allow water to drain. If you install it in the proper way, which we will talk about at some point, you won't have that problem. If you're going back and trying to, well, if the window sill hasn't rotted out or the wall below it, the sheetrock, it doesn't have mold on it, then it may not be a problem because it's a microclimate problem. It's sometimes if the window's in a place where the rain doesn't blow against it, it won't go in those places. If it's right in the face of a place where the wind hits the house and the rain gets shoved in it, that's where the damage will be. And you'll see the damage on the inside. If you don't smell mold or see it around the window, you may have been lucky and you won't need to do anything. If there's a problem, then you'll have to take the window out and redo a lot of stuff anyway. So there won't be a simple solution. You know, dealing with window problems and leakage around windows is one of the biggest callbacks in construction. So it really pays to know how to put the windows in right the first time. Then you'll look at the heating and cooling systems. Those are changing like crazy now. You know, we've got all this heat pump technology. I want to show you some videos on heat pump heaters and water heaters and cooling systems later on in the class. That industry's jumping. And it's so much easier than HVAC, than the standard HVAC with the, you know, the ducting all throughout the house. Then baseload energy use is something you get from their energy bills, and then health and safety issues. So some inspections. Remember I said there's a lot of levels of inspections. The one we saw, the guy had a infrared scanner. So some don't have any equipment. You just go in and look at the windows and look at the, you know, look at the basement, look at the heater, and if the ducting's going up instead of down, you know, on the exit. There's a million things you can just look at visually and do. So the cheaper, simpler audits will just do that stuff. The next level is having some degree of equipment. This guy looked like he didn't do a blower door test, but he just did a scanner. Now, that's good in New England because it's cold out and you can get good scan readings. So maybe that's all they use there. But next level up, they'd use a duct blaster to test the duct system in the house, and then a blower door to test general leakage. So, you know, it just keeps getting more involved and more thorough and it becomes more expensive because you have to pay for this person doing these tests. So, you know, all through this course, we'll look at what calls for tests and, you know, what, as an owner or you know, builder, what you need, what's most appropriate for you to do in various cases. So we talked about the outside. We'll look more about this later. Look at foundation, roofing, siding, windows, doors. And then scanning. That's a really good way to do it. No matter who does it, that would be if you're using diagnostic tools, that would be one of them. You also might look at shading because, you know, your house might be overheating and you might have some trees nearby that could be used for shading. So the outside site contributes to heating and cooling and wind resistance also. So all those things you'd notice. Okay. Is this the next one? Oh, the numbering got screwed up somehow. I put them in order. 18, 19, 22 now. There we go. So, and then the interior, right? There's just a picture of some of the things that can be damaged plaster that may have leaks. Plumbing penetrations are notorious. Plumbers don't really caulk or fill around their penetrations. They expect you to do it. So they try to keep them the same size as the pipe, but occasionally you'll see people that kind of butcher the openings and you really have to deal with that. Windows could be leaky, chimneys could be leaky. Here you've got your HVAC equipment, you know, your hot water heater and maybe your furnace. And this is called a combustion zone. We'll talk a lot about this in later units because there's not only energy problems here, but there's fire and CO problems with combustion zones, which are health issues. So thermal boundary, they used to talk about a lot. I don't think it's a particularly good concept unless you get a company. I don't know if hers goes nuts on that. If they do, you'll have to learn it. But I tend to think it was more confusing. The thermal boundary just means the boundary that keeps the heat in. And what they do is they want you to see how the thermal boundary doesn't always correspond with the whole house. They may leave things out of the thermal boundary. They used to leave the attic out of the thermal boundary. They put insulation here, and this would be open to vents and it would be cool. But you also had your HVAC equipment here, which functions, which loses energy in a cold area. So now they're advocating warming that area, including that attic in the thing. And then same thing with these underground dug in basement crawl space areas. They may not be in the thermal boundary. It might come here along the bottom of the floor system, and this could be not thermal, and then there could be leaks in there. So they're trying to show you how to check out the thermal boundary. Checking insulation, we're going to do a unit on that next week after next. Looking for large air leaks, measuring the building's floor space and volume, because some of the calculations you do require those. Get your nose out, start smelling for mold, water stains, musty smells. The residents will usually have a lot to tell you about that, and drafts, because they live in it. Then the wiring may be crappy. Vermin may be eating away at it, maybe knob and tube, and just all kinds of problems with wiring, and then other health issues. The heating system, you go down here, you have to make sure, we'll talk about spillage and backdrafting and flame rollout when we do the BPI stuff later in the class. Yeah, making sure combustibles are not near the water heater. People put paint cans and solvents right in their little closet next to the heater. Not a good idea. Sometimes the vents are going the wrong way. They're downsloping away from the appliance. All kinds of problems with HVAC. Yeah, so we have a whole unit on that. Cooling, same thing. So the term base load inspection is contrasted with seasonal inspection. And these are kind of old terms, old school terms. Some places still use them. But base load is all the stuff that you use all year round. You use your water heater all year round. You use your refrigerator all year round. You use your lights and your clothes dryer all year round. So base load, that means that's just your background. Then you have seasonal, which is mostly heating or cooling, right? Santa Barbara, we have very little rise in the heating or cooling. If you go if you go to North County or over the hills, you might have more of that. But in Santa Barbara City, Goleta, well, I'll show you a graph. You're not going to see a lot of bump on the seasonal. You can look for things like dust on the refrigerator coil that allows it not to cool sufficiently. You can measure all your appliances. You've got these little tools you can plug in and measure how much electricity they use. You may have an old refrigerator. They'll monitor that and then compare it with what the new refrigerators run and show you how much energy you're losing. It might be an inducement to buy new appliances, stuff like that. Okay, 20. Was that page 20, 21? We want 22, right? I was here looking at the water heater temperature. A lot of things just in adjusting temperature values in heaters and furnace and stuff are really important. Dryers, you've got the whole lint problem and the venting problems. And then you can change your light bulbs out. That's pretty much current stuff. Health and safety things you can look for. Carbon monoxide is the most important. And now that we're required to put carbon monoxide meters in our homes, we got a head start on that. People die from this all the time. Just in the Hurricane Ida that hit New Orleans, right? Everybody aware of that? I think they had a death already from one guy was saying the only way you can get energy is by a what do you call it? A generator, thanks. And people are using generators in their homes, and they're leaking exhaust and they're leaking CO. People get sick and die from that all the time. So it's alive and well in emergencies and just any place. Then you've got CO issues with your stove and with all your combustion equipment. We'll go into a lot of detail on that later. Moisture problems, got to look for that. The homeowner will know a lot. You know, my daughter lives in this room and she's been real sick, so we moved her in another room. So you know to look at that room for mold or anything, you know. So and then so that's the visual inspection, and then the next step would be diagnostic testing. Blower door is the most famous instrument. We'll show you a setup and do a unit on that. Duct testing, we'll do a unit on that. Combustion safety and testing, we'll do a unit on that. Infrared scanning will be in the blower door unit. And we won't do much HVAC diagnosis. This is an old thing. When you have forced air heating and you have ductwork throughout the house, you have to balance the ductwork. So sometimes HVAC people would give you too big of a unit. They would just do it off the top of their head and not actually consult all the government engineering publications that take you step by step through sizing. And sometimes you'll end up with too big or too small. Usually they don't like it too small because people complain about that. But if it's too big, it'll go on and off too much and it'll really eat up your energy. So, but we're getting away from duct. We're getting more into heat pumps room in various parts of the house. So the new direction is kind of away from ducting. So that may not be an issue in the near future. Numerical analysis is putting it all together, showing, you know, blower door test, you have to show how much volume in cubic measurements of volume is leaking. So there's all kinds of numbers involved with these diagnostic tools, and you just have to know how to do them up. And then you want to print out. You want to, if you're using a program, you want to input everything and then get a printout that shows the results of all that analysis. So that's part of it. And a lot of these programs take measurements. You have to throw in the cubic footage of the house or the square footage or whatever. Let's see, 23. Computer modeling, yeah. There's programs out there. We won't look at that. Here's where they're going to talk about baseload versus seasonal use. This is a place like in, where is it hot and cold? Well, it could be in the Rockies, get that way. They get actually pretty hot, or even like, say, Michigan, the Midwest, upper Midwest, the summers are really hot and muggy and the winters are really cold. So these would have big seasonal peaks like this, spikes. But then Santa Barbara is more like this. It's kind of, it's kind of the same. You use a little bit of cooling for the summer, you use a little bit of heating for the winter, not much. So it's just a small stack on top of your base load. These distinctions are good for some calculations. That's the only reason you really need to know about it. Damn it. 26 we need. Here. This is going to go into base, so let's skip that. Here's something, though, that's interesting. There's a lot of graphs in this handout, and they're all interesting. Here's the top 6 energy uses for U.S. households. Now, this is, they give it in natural gas therms. That's the measurement of gas. Like it's like so many BTUs per therm. And then this is kilowatt hours. This is electrical. You know, gas is going out, right? New houses can't even have gas anymore. So this is only going to be good for a while longer. But heating takes, if it's electrical, it takes this much kilowatt hours. If it's heating, it takes this many therms. Cooling obviously takes less, right? You know, a fifth of this. Water heating, though, look at how water heating, that's pretty close to that, huh? That's amazing, isn't it? Well, we're getting more efficient water heaters too. That's electrical. Gas water heaters. Look at the difference in a gas water heater. Of course, these aren't the same measurement, but gas are more efficient for sure. And refrigerator, electrical shows you how much, lighting, clothes dryer, etc. Okay, so we want 28. With any luck, it's right here it is. Yeah, we won't do this. This is just doing certain calculations. You probably won't do them unless you're doing a do-it-yourself audit, and then you can read this. Otherwise, whoever's doing your audit, if they're using these utility calculations, they'll get all this stuff from the bill and they'll just hack it out in their program. Here's another graph that's really interesting. So HERS, I told you about the home energy rating system index. They've created an index that compares houses with how much energy they use. And they've got a kilowatt hour for square foot for electrical homes and kilo BTUs per square foot for gas homes. So very inefficient homes, a lot of what we are living in, you and I, have pretty high index. Average existing homes, if they're built after the 70s, say, they might be a little better. Energy Star homes are a lot better. It's one of those programs that really looks into energy efficiency. And then passive house, we're going to talk about that. That's the most. Zero energy and passive are the least energy using. So it kind of gives you a comparison of what those numbers are, if that's interesting to you. Carbon footprint, a lot of talk about that lately, right? So here's a graph, this went to the page forward. Here's a graph that shows the carbon footprint of various energy forms. This might be interesting to some of you. So the gas is in CO2 per therms, and the other things are in kilowatt hours or cords. So this is kind of hard to compare because it's just a unit, but this is what you want to compare, is the CO2 per unit of heat that these things offer. So natural gas is actually not bad. Remember, that's why they call it a transition form from coal and oil create electricity to natural gas. It's still up there, but it's quite a bit less than those others. Propane's actually a lot more, so propane's less efficient. Fuel oil, which they use back east, we don't use it here. Big furnaces back there use that. Look at that. That's really inefficient, and yeah, the whole East Coast uses that, or the Northeast. Wood, 21 pounds, so it's throwing in quite a bit of. So there's where wood stands in terms of natural gas and electrical stuff, just to get you oriented. Electricity from gas. So electricity is made from different things. So depending on what it's made from, it creates more CO2. So obviously if it's from gas, it's the least. Oil and coal is really the worst of all, right? That's the highest number. So we're really trying to get rid of coal energy plants. So the average of these three is 45, so it's way up there. So natural gas is a good thing. And of course, electricity, they don't list sustainable electricity that you get from, well, you may get it from your utility, which has a mix of wind power and solar power and hydropower. In fact, you can specify getting your electricity from sustainable things. Did you know that? In your utility company, you can say, I want, and you may pay a little more depending on what their relative cost is. Sometimes they surpass, they're cheaper than the usual. But yeah, so a lot of this is going to disappear as we go to electricity from solar and electricity from thermal, and there's a lot of sustainable fuels that are still being researched. They've been in the research phase for a long time, but algae for combustion and tidal energy, there's a bunch. So Work scope, obviously you have to figure the work scope when you make a contract. Let's see if we can get from 33 somewhere. Oh, good. We won't go into this, but it just tells you about contracts. If you're going to be an independent auditor and set up your own business, you need to be aware of this stuff. There's a lot of stuff about customer relations that we'll talk about. Just because when you're auditing, you can't be an oaf and go in and, knock over things and be rude to the client, right? Okay, so pre-inspection survey. This is one we developed in our classes. Sometimes weatherization work is preceded by an energy or a whole house audit. This involves surveys, on-site inspections, energy calcs, and recommendations. However, weatherization work can be done with an initial on-site visit that determines the various opportunities. With this less involved sequence, you might want to make the initial on-site inspection more efficient by having mailed or emailed a brief survey that the client can fill out and send back to you. So this just saves you precious time. You can't charge an arm and a leg for an audit, right? It's got to be reasonable. The money's going to come in having people retrofit their houses. They don't want to spend half of it on an audit. So you're limited on what the public will accept. So efficiency in your operations is really critical to make any money. So this is a sustainability audit. So it's bigger than the energy. So it asks some questions. Are you interested in the audit in order to save money on utility bills? Everyone's going to answer yes on that. Then are you interested in the audit in order to lower your carbon footprint? You can all see this, right?
Yep.
Okay. To lower your carbon footprint or use planet resources more efficiently. And now more people will say yes to that too. And then this is the one that we're headed toward. Sometimes there is hidden embedded energy or toxicity or ethical issues involved in some aspect of the life cycle of a product. Are you interested in using resources that are as green as possible? Some people, there's, solar energy panels. You guys ever seen a panel up close?
No, I don't think so.
Well, I'll show you one at some point. They're pretty intricate, they're, what do you call electronics when you burn it all, when you burn the circuit? It's not actual wire, you kind of
PCB.
No, it's it's like solid state. You kind of you metallically print the circuit onto the board.
Yeah, printed circuit board, PCB.
Okay, that's what you're saying. Yeah. So there's embedded energy in that. It's complicated. It uses resources to do all that, right? So even though the solar panel is bringing you electricity, which we need to get out of green gas global warming problems, it's still using up a lot of energy and resources in that particular technology, right? So, concrete's another one, and we won't get into it here. We do that more in the green building class. We evaluate building products, but concrete's a great product. I mean, look at it. Once it's inert, once it's dry, it's inert. It doesn't shed any kind of toxins. It's there for a long time. It's easy to work with. We've just relied on it for hundreds of years, but it's a bitch to make. It has a lot of embedded energy. It takes a lot of energy, which they're trying to use solar and do sustainable energy, which will help. Also has a lot of toxicity, also creates a lot of greenhouse gas in its production. And even though people say they can recoup that gas and screen for that gas, the screens break down a lot, and we've never had really good satisfaction. So cement has a lot of embedded energy and toxicity involved in its production. So if people are aware of all this, which more and more of us are, they may say, yeah, I want stuff that's as simple as can be, doesn't use a lot of energy to create, or a lot of rare materials that we won't have eventually, isn't toxic. I don't want it toxic even in the production. I don't want the people who make it to get sick. And I don't want it if it involves hurting animals or using labor of indigenous peoples that they're being held captive, you know. There's some real messes on how these things are mined and produced. So that may be an interest too. So, and then you've got just information about your house. This describes your house. Do you own or rent? That's important because if you rent, there's a lot of things you don't want to pay for or can't pay for or can't change. How much you occupy, how many stories, that makes a big difference in a lot of heating and sealing. Some of the stuff you'd never, oh, darn it. Hold on. That couldn't have been the end of it, could it have? I know, you're all going, I know. Maybe here, no. Huh. Now it's working. Oh, well. So this is more information about your house, how many rooms, square footage, number of people there, how old is your house, windows, describe your leakage, draft around windows.
Patrick,
So-
we just see you.
Oh, darn it. Thank you.
Yeah.
So maybe it won't work if I do that, but let's try it. You can only try. So you can see it now, right?
Yep.
Yeah, can see it.
So this is just more of the information about the house, number of people living, how old, windows, then describing drafts in the house. That's really good information. You would ask them that when you get there anyway, but if you know, then you're going to check that off on your list. When you interview the folks in the house, you're going to say, okay, you said something about draft in, you know, this bedroom, and then you can zero right in on it instead of having to, you know, ask them, oh, you know, you have any drafts? So you can prepare for a lot of this ahead of time. So here's the energy audit. After just general home information, then you want to find out about all their heating issues, what they're heating with, what kind of appliances they have, programmable thermostats, because that's a really important thing to replace or to have. Attic insulation, wall insulation. They may not know. Sometimes you can guess by the thickness of the wall. Sometimes you just have to sometimes you'll know by the year of the house. You can still see these, right?
Yep.
Okay. How often do you use your additional heating system? It's just, you know, it's a lot of really nitpicky information, but it will really help them make their house more comfortable and efficient. Then you go into cooling. Oh, wait. Then you go into water heating, because that's a real, you know, inefficient thing, and you want to know all about their water heater. Then more about their cooling, air conditioning, any of that stuff, whole house fans. Then because this is a sustainability audit, not just an energy audit, we want to audit their water use too, and how much they're, because you know, if you use water inefficiently, you're paying for a lot of extra water also. And these days, pretty soon we're only going to be allowed so much water. So you find out what the shower heads are like, if the toilets leak, you know, how old is the toilets. You talk about the fixture showers, you know, their behavior. How many showers does your family take weekly? How many teenagers taking showers? That kind of thing. Then this is another added thing, indoor air and water quality that an energy audit doesn't have. But I think these are, see, we were trying to do a whole house audit. that it covered all this stuff. And I think they'll start going more and more to that. They're still energy oriented with a little bit of health and safety, but I think it's all this stuff's important. I mean, water quality, water efficiency, how important could that be in Southern Cal, huh? And then air quality, ventilation, odor problems, allergies, mildew, radon gas, laundry, outdoor water use, just your habits, how you water the landscaping, furniture and cabinets. I don't know what this is. Household cleaners, combustion. This is a clean air still. Household cleaners, are they stored in the house? Are they not green? Are they just off the shelf? Are they used with ventilation when you use them? Are the windows open? So there's a million things that have to do with their health, not just their costs of things, but the health. Combustion acids, we'll talk a lot about that. Water quality, that's not so much of an issue here. We have pretty good water here. I mean, at least it's pretty clean. It doesn't always taste good, but a lot of places in the world, well, in the States, you really should have a softening or a purification system, make sure the water is okay. And those, cost varying amounts. Okay, I know you guys can't believe this, but we finished the handout. Yay.
Very nice.
So even though a few of you may end up working for a company like hers, or somebody that does this kind of auditing, and they'll take care of it. They'll have a whole system. Even when you train with hers or BPI, having a background, just what we went over in the audit, will really help you understand that stuff. Because they're going to go into theirs. It'll be a variation of that. All of them will be a variation. They won't have the whole house necessarily, but it will really behoove you to know that stuff. And especially if you take training where, the training, they don't just approve everybody. It's pretty rigorous. BPI training is really rigorous. And a lot of people fail it because they don't want people scamming people or doing crappy jobs. And you go through a slideshow lecture thing for a week. It's pretty elaborate. And then they give you a written test, and then you do a field test, and they secure a house in say they're doing the training in Santa Barbara, they'll secure a house in Santa Barbara, and you're going to go up, and your trainer's going to go through it, he or she, and walk you through the house and then tell you what you have to do. You have to do a blower door test on it. You have to look at, all the joints of the gas flexes and just all the things on the list. And you only have a limited time to do it in the test. So what you have to do is make sure you know how to do everything you need to do down cold. So the blower door is fairly complex. So what I do is, when I used to give my class, I'd say, if you're going to take this test, get a hold of me and we'll get together and we'll run through the blower door setup and test a couple times before you take their test. And that'll give you familiarity, and then you can cut the time down. If you have to spin and scratch your head setting up that test, it's going to suck up all your time. So there's things we can do at the school to prepare you for that if you go into that. It's not just a simple thing that everybody passes by any means. I think they've made them too hard. They go back and forth. They get a lot of negative feedback from the public, saying, hey, we're not PhD candidates. This stuff's too damn hard. And they'll make it a little easier the next year. And then, so it's been growing, but the reason I go into this stuff, you may say, well, why do I need to learn this hand audit or this simple stuff? Because it's all based on these same categories. And it's just to get you thinking in those terms. So that's why we do it. So I'm going to show you one more video, which isn't long. Let's not take a break because this video is short and then we'll go home. Yeah. Is that okay? Can everybody make it? It's a hers thing I found on YouTube. So we'll look at it just to show you what the upper end of this auditing is about. And it tells a little bit about hers. We're going to talk about it off and on the whole time because it's so involved in building inspection now. But let's start with this thing. So let me set up my my YouTube. That would be, where is that stupid thing? Here it is. Okay, so we go to.
You booked a spacious Verbo summer home with a pool big enough for the most epic cannonballs. But the thing they'll remember forever,
What's up, guys? I'm Nick Schiffer, and on this episode,
Hey,
we're
what's
going
up,
to be
bud?
talking about a HERS rating and just what that is. What's going on, Russ?
Nick, how you doing?
Good. How are you?
You shut this down?
How we doing?
Great.
What are we leaking?
House came in 1,009 CFM
And that's throughout the whole house.
throughout the whole house.
So we're
Gonna do a blower door test and look at all this equipment, so don't worry about the numbers and units right now.
probably somewhere under 2.
Or yeah, just under 2. I got to work out the final math, but I'd say that's pretty realistic.
It's not bad. So you're here, home energy rating.
Remember that graph, pardon me, remember that table we saw when I was going through the handout? It was the HERS rating table. And it had, efficient homes, normal homes, and then it had passive Energy Star and then passive. Remember that?
Yeah.
Well, that's the number system he's referring to. So this house did a 2. It's
You
pretty
guys are
good.
putting together
Pretty good to begin with.
HERS rating. What is a HERS rating?
A HERS rating, HERS stands for Home Energy Rating System.
Okay.
So HERS rating is the industry standard for measuring a home's energy efficiency.
And that's beyond the blower door, right?
Exactly. We're taking a holistic approach at the house. We're looking at windows and doors, insulation, appliances, mechanical, lighting, basically everything that goes into the house that affects energy performance.
So light usage, is it like the wattage?
It's the wattage, yeah, exactly. The difference between an LED and an incandescent bulb, 2 completely different loads.
So when I first got here, I saw you looking at the appliances. What's the reasoning behind that?
Well, he was just
every
trying to make a
appliance has got one of
sandwich.
those yellow energy guide labels on it, and that tells us how many kilowatt hours per year that appliance is going to use. So we want to put that into our rating because that's going to affect the energy usage of the house.
So at the end of the day, to simplify it, are we looking at what this house is going to require, or how much energy this house is going to require in all assets, and we're reporting that back to, the municipality here that is looking for a rating?
So what we're going to be reporting to the municipality is a HERS score, which is used for code compliance. The energy usage is a little difficult to say this house is going to use this amount of energy. Everybody lives in a house differently. Your
course, lights on,
thermostat
lights
set
off,
points are going to
right.
be different than mine.
Sure.
If you've got 6 kids at home versus 1 person, laundry loads, dishwasher loads per week are completely different. So it's kind of a standardized across the board usage for some of those appliances, so we can measure one house against another.
So we have a blower door test that we're doing. We're doing the ACH, air changes per hour, throughout the whole house, and that's really based on air tightness and insulation values, right?
Predominantly air tightness. Heat loss through a house, mostly through 2 ways. It's going to transmit the heat energy through the assembly, and that's what the insulation is going to slow down. And then it's the air leaks through the house, that heated air or cooled air in the summer is going to actually just escape. So we want to see how leaky the house is.
I think Nate from Zone 6 actually said it really well on one of the Modern Craftsman episodes. It's like wearing a sweater without a windbreaker. It's thermally warm, but once wind starts blowing, it's going right through and it's cold.
Exactly.
And it's the same thing here. If air can escape, heat can escape. Now, we're also going to be testing the ductwork.
Exactly, yep, we're going to be looking at how leaky the actual ductwork is. In this particular house, it's all inside the thermal envelope, but we want to make sure that air is getting delivered to where we want it to be delivered.
Why is it important that it's inside the envelope?
So if there is leakage outside the ductwork, technically that energy is going to stay inside the area that you have set to be conditioned, the insulation volume.
So here we did what we call a hot roof, so the entire roof is foamed, and that equipment is within that space. If heat is escaping, it's really not being lost into cold air, where, maybe if in Boston we deal with air handlers that are outside, ductwork is outside. If that was escaping, that would be a much bigger issue.
Exactly. The air that's leaking out is staying within the thermal envelope, but we want to make sure that air gets delivered to where it's meant to be. If it's leaking a lot, you might have a room that stays cooler in the wintertime and is too hot in the summer because it doesn't get enough airflow. The system is designed to be a certain tightness, and the airflow through that ductwork may not be sufficient if it's too leaky.
So what are ways that we correct that?
So there's a couple ways to do it. You can have the HVAC company pay a lot of attention as they're installing. That's really the best way to do it.
Duct seal, duct tape, making sure that their connections are really tight.
Exactly, and having a good design of a system. Manual Ds are important. Manual J is important, which is the heating load for the house.
And we talked about the manual J on one of our first episodes when we were engineering the comfort of the house.
Yep, exactly, and most code requirements specify a manual J. In a situation where you come into a house and it's at the end, there are some ways to seal the ductwork. Aero Seal, which is kind of a cousin to Aero Barrier, seals ductwork from the inside. That's kind of a 911, I'm finished my house, but it's too leaky, and I don't want to open everything up.
Or in a situation where it might be an old system and they're trying to, improve the efficiency of it.
Exactly. If you're salvaging old ductwork, you can seal it up with that product.
So when does someone need a HERS rating?
It varies. A lot of code requirements now in Massachusetts, any town that's a stretch code for new construction requires a HERS rating.
What's a stretch code?
Stretch code is a voluntary energy code that towns and cities in Massachusetts can adopt, along with a few other things.
So everybody has to comply with a state code, with the standards of a state code. The state code complies with the national code. The national code complies with the international code. So you can't get any lesser standard than any of those codes, but you can go stronger. So, California goes stronger in its emission standards for cars. We pay all that extra money for our gas to make sure it's, it doesn't get into the atmosphere. And same thing with these stretch codes. Different cities we have them here in Santa Barbara. They just are extra requirements for, in this case, for energy efficiency and insulation. So that's what those stretch codes are. It's a way that cities can actually go more deeply into the standards.
To improve their energy efficiency.
As a town.
As a town.
Right.
And in exchange, the state gives them some extra funding. About 85% of the cities and towns in Massachusetts have the stretch code, which means in order to pull a permit for a new home in those towns and cities, you have to have paperwork from a HERS rater.
So you're going in, here is a unique situation where this originally started as a renovation, turned into a new home. So we're actually doing this HERS rating at the very end of the job, where normally you guys would be part of that process all the way throughout, right?
Exactly. So we would give you paperwork to pull your permit based on the plans and specifications of what you're planning on doing with the home.
Sure.
Then we would come in pretty much as the ductwork is being finished, test that, make sure it complies. We'd also look at the insulation, document what's there, grade the insulation too. How well was it installed?
Sure.
And then after we do that, we come back at the end right about now and we do our blower door test. We test the ventilation. We gather some other data about the mechanical systems, appliances, and things like that.
We're talking in regards to the fresh air that we're pulling through the ERV, right?
Exactly. We want to know how much air is coming through that ERV because we don't want to overventilate the house and we certainly don't want to underventilate the house.
Sure.
So if we can get it in that sweet spot, that's a great product.
We talked about in the last episode regarding makeup air and keeping the house balanced. If you're exhausting 1200 CFM of kitchen exhaust, you want to be bringing in 1200 CFM to keep the house balanced. Is that the same thing with the ERV if you're bringing in too much fresh air?
Not quite the same balancing issue. You can ventilate the house with an exhaust only or an intake only.
Where the ERV is both.
Where the ERV is both. And it's also exchanging temperature across those two airstreams without coming into contact. So there's multiple ways to meet the ventilation requirements set forth in the building code. ERVs and HRVs are the best because they do balance the air. You're not having a pressure differential. And they filter the air.
Right.
There's a lot of other methods that we're just bringing in air unfiltered. We don't know what's in the air. We're not controlling it for temperature or humidity.
You made a comment earlier off camera, and which was really interesting. I wish we hit it on our last episode, is how an ERV and an HRV is different. And we talk about the technical side of ERV can transfer humidity, but I never asked the question as to how. And you made the reference that the filters are different.
Sure, the core where the heat exchange happens on an HRV, which is only transferring the heat load, that core is more of a corrugated plastic material usually. In an ERV,
so it's impermeable.
Exactly. Where the ERV, where the moisture is being transferred, it's more of a paper core, where that water can absorb into the paper and migrate to the other stream.
With that being said, what's the negative side of overventilating?
It's difficult to put a holistic approach on it. You're going to use more energy. You're going to take out more heated air in the wintertime, more cooled air in the summertime. There's some other parts of it. You really want to talk to your HVAC contractor and find out what the requirements are for your house. Every house is going to be a little different, so you find out what the requirements are for that house and design the system to meet those requirements.
How are we doing for our HERS rating?
It looks good. Everything that I've seen fits well within the tolerances where we need to be to comply with the energy code, and probably be pretty significantly below that.
That's great.
In Massachusetts, the target is 55.
Okay.
HERS scores like golf, lower is better.
Sure.
So below 55 is great. Above 55, not so great. Then we usually have to find some other way to get it below. I know we talked off camera before about laundry being a pretty important part of the HERS score. So we can add laundry machines if there aren't laundry machines in the house. And that can overcome the default setting that we have to use if there aren't.
Because that default setting is assuming...
It's assuming a pretty bad efficiency washer and dryer.
Sure. And then if you have something more efficient, bringing that score down.
Pretty much anything you can buy today is going to improve that score.
So this is probably more opinionated, but based on, you know, doing these ratings kind of on a regular basis, where do you see construction falling right now? Are a lot of them being, you know, just under 55, or are we working towards a much lower score?
So the trend has been to meet code, and a lot of guys are meeting code without a problem.
Sure.
We are seeing a trend to start to skew below code, which is great because we want to be more efficient. So
below
we are
code
seeing
number-wise.
Number-wise,
Right.
so we're seeing lower scores. There's usually a segment of the building industry that's shooting for those really low scores, people in the 40s, without solar. Solar will also bring down the score. So
Yeah.
in a case where a building might come in at 65 or 70 because of some condition that can't be overcome, there's always an option to add solar to bring that score down.
It's interesting because you're bringing basically everything that makes this house function, you know, and rating it and then tallying that up and hoping for a low score.
Yep, and what we would do at the beginning is when we give you paperwork to send to the building department to pull your permit, we've already modeled the house and come up with a set of worst case assumptions. The blower door is just barely going to pass.
Sure.
The ductwork is just barely going to pass. You have awful equipment in the house.
You're basically narrating like, hey, do this or better.
Do this or better. And that way we're pretty confident that as long as you do that or better, you'll be below that 55 where you want to be.
Now, the last thing I want to touch on is rebates, because, you know, as you become more energy efficient, there's rebates out there that allow you to kind of offset some of these costs.
Absolutely. Mass Save, which is a group of utility companies, offer what they call pay for savings. So the more energy efficient your house is, in the new construction program, they have a special rebate where it's a curve and you can have your house anywhere along that curve, and the more efficient it is, the more money they're going to give you.
Every state is going to have different rebate programs. So we recommend, you know, getting in touch with your local HERS rater or energy consultant. And as always, guys, we appreciate you watching. Stay tuned for a future episode. Ross, where can they find you guys?
So our company's Home Energy Raters, energy code.
So that was a Massachusetts company. Hey, hold on, I'm in the dark. It got dark. So that was pretty straightforward, yeah, that video. So I don't know what all the jurisdictions, building jurisdictions in the area, if they have stretch codes that require a HERS rating on a new house. So I'll check into that. You know, there's a lot. There's the county, there's the city, there's Goleta City. But I mean, it's going that way. That's the trend. California is like Massachusetts. They're very conscientious that way. But yeah, so that's it's getting down to numbers now, huh? But what's cool is that if your house doesn't, if you have a new house and you have a stretch code that says you have to be under this number, like we saw in the film, it was cool that there were there's several single item changes that can often help you get below that number, like getting a more efficient clothes dryer, which is a nice thing to have anyway if you can afford it. So, or solar panels, you know. So there's some easy fixes. It's not like you have to tear the house apart and go look for holes in it, you know. We'll look at, they mentioned that what was that thing called? Barrier. I forget what it was called, but it's we're going to look at that. It's a machine that fills the cracks by a blower door pressurizing the house, and the air leaves in the cracks, and it takes with it this spray of particulate that gets stuck in the holes and fills them. I think it's the greatest thing since sliced bread. And we'll look at that. It's really cool. So leave it to technology. They bail us out one more time. Anyway, next week's a holiday. Don't show up. No one's going to be here. And read the material for the week after that, the fourth week. It'll be on insulation. It's not a lot of reading. We're going to talk about heat theory. There's a page on there. Maybe it's just an outline. It may not be understandable without me explaining it. So, don't worry about it. But yeah, that's what we'll do next week. We'll do insulation. Remember, he said there were two main things. Insulation, because the heat goes through the wall, through the assembly and leaves, and you want to slow it down. And then leaks, which just takes the hot air and lets it out. So insulation's one category we're going to do a week after next. And then sealing, which is now getting more attention than the insulation. Insulation for so long was the big sexy thing. Now it's getting towards sealing. So we'll spend some time on diagnosing holes and how to fill them in the units after coming up. Okay?
All right.
Everybody
thanks,
okay?
Patrick.
Sounds
Okay,
good.
any problems? You're all good?
Patrick, did you take roll?
I didn't take roll. Why don't we take it right now? So, thank you for reminding me. Miguel.
Here.
Jesus.
Here.
Yeah. Alec.
Here.
Lewis.
Present.
Jack. Jack was here. Dylan Forbes, you were here, right?
Yeah.
Adair.
Here.
Zach. Eric.
Here.
I'm right.
Yeah. Dylan Mitchell.
Here.
He's here. Jocelyn dropped. Joel Santos.
Here.
Michael Silva. I've seen most of you on here, but just answer.
Here.
Michael Silva. Jose Silva.
Here.
John Tapia.
Here.
And Gustav, our Dutchman, dropped. Damn it. I love having Europeans in class. They're a lot of fun, but I think he was just starting to get in a building, and this is a real technical side of building. He probably thought, that's not building. So this is a technical side of building, and I believed in this because I've seen global warming coming for a dozen years, and also I've seen people get sick in sealed houses. So I've pushed this for a long time, and now it's becoming part of the whole regime. So it's good for you guys to have this overview of this, because if you're working for someone, you can suggest things. If there's problems, you'll probably know more than your bosses. If you've got your own companies or you're doing this work, then you need to know this stuff anyway. And now that it's embedded in getting code compliance, we're pretty much stuck with it. So it is technical. It's not a lot like the building you normally do and love. I'd rather pound nails and think about all this crap myself, but it's here to stay, and I'm trying to prepare you guys for the future. So that's why we have this class. So bear with it. It's not the usual kind of stuff we do or are interested in. Okay. All right. See you guys in 2 weeks. Yeah.
Yep. Have a good one, Patrick.
Do
Thank
your
you.
homework,
Patrick.
I'll get a blog in tomorrow, and do journaling if you can. All right.
Patrick, can you talk to me a bit about what you want from journaling?
Yeah. Who's saying that?
Austin.
Oh yeah, I can.
Just because I was gone last week.
Yeah. So it could be anything. I'm just trying to get people to put their ideas down on paper. A lot of times people go into construction, don't do that very well. And it's pretty important. I mean, even in this stuff we're learning now, it's a lot of writing and computing and stuff. So they could be reactions to the class. I really like that YouTube, or that last YouTube was ridiculous. Why did you show us that? Well, don't be nasty, but And I'll probably have a question, a prompt for the, no, that's for the discussion. I won't have a prompt for the journal. Just any musing you want. It's just to get more writing in.
Okay.
And I'm not going to grade it. I'm not even going to read it. I'm going to just
Yeah, I
look
saw
at it
that.
periodically to see that you're doing it. If you're paranoid and you think I might read it because I'd like to get into people's minds, which I don't, you can do what that one student did and hide it and give me the access code. So I don't care.
Otherwise, yeah, where are we posting them? Just in the
Yeah, when you go to journal, it'll
just
be
click
right
on the
there.
journal for that
Yeah.
week. Okay.
And if
I
you
see
don't,
a couple people from last week did it, but
yeah. So just follow that. And with the blog, there'll be a prompt and you can address my prompt or you can follow up. It's like a blog. You can follow up on what someone else said, or you can say nothing. You can say, blah, blah, blah. I don't care. I just wanted to get you guys to think and write a little bit more than the class. Okay.
okay.
Yeah. All right. Any other questions before we go?
Yeah, I've got a general question.
Sure.
This is about the CT department. So I noticed that in the course catalog, there's a whole ton of classes that I haven't seen offered.
Yes.
Can you tell me more about if there's a potential that some of those will be offered in the future? Or I know the department's kind of been in flux for the past couple of years.
Yeah. The only thing that the flux has done is slowed us down. We can't offer as many classes per semester. So we've had rather than just trying to catch up, we kind of ask students what they need and we take what the majority needs. We've been doing that to make up for it because we don't have any other way. We'll come out of that eventually. I don't know when, we're applying for a full-time to replace me. I retired and I'm just working as an adjunct to keep it going. And we've got someone lined up. So if the Senate, and we've got money from, what's his name? Bezos, his wife, gave us a lot of money to the school. So I'm hoping we'll do that. But anyway, there's 10 classes that are required. I don't think there's any electives right now. And students didn't take the electives, so we never could fill them. We've offered them in the past, but there's 10 required. And then with those 10, you get a certificate. And then if you get general ed classes, there's a handful that require the AA degree. It's an AS, Associate of Science with our program. You can do that, take those extra, or maybe you already have a degree. I don't know. Some people already have AA degrees or even BA degrees that take this because they just want to learn this stuff. So
yeah, that's
all set. Yeah. Okay. So, and we offer those classes as best we can, but we offer we're offering all of them. And hopefully after this year, I do have a full-time person that's pretty good. We've looked at him lined up. So if the faculty gives us permission to do it, we'll hire him, maybe hire another adjunct, and we'll continue. And we'll be more on schedule. It'll be more timely.
So you think there's going to be a potential in the future to see some of those more specialty courses?
Well, all of them that are listed are required for the certificate, so we'll offer those.
Oh no, I mean
I'm
saw
sorry.
things that have to do with electricity or outdoor structures or things that seem more elective.
Yeah. So there's a credit program and a non-credit. I assume you were looking on credit, or were you looking at both?
I actually looked at both, but I'm primarily referring to the credit ones that seem more elective.
Yeah. The non-credit, Jim likes teaching those now, Jim Cunningham. So as long as he continues, we'll have those. I never liked him teaching them because I wanted him to teach in our program, but he just really likes that setup. So he does that. But the outside structures was a class I started, and we built a gazebo in that Japanese gazebo at the Wake Center. It's a really great class because there's a lot of outside building, and gardening, hardscape, and all over. But we couldn't fill it. After the initial one, that was pretty exciting. I sort of bent a few arms to take it. People just want to take the required ones because they want to get in and out,
Mhm.
But we could offer, and even if I'm not here, I'm going to be here through summer. I'll write down stuff for my adjuncts and this new chair to do. We can offer that, and then just don't teach it if it doesn't fill up.
Mhm.
That's a class I really regret not being able to offer because it's really good. I think the classes for helping people do electrical repairs in their home and little simple things with machines and stuff would really be useful for people.
Mhm.
It's not part of a building program, so my deans have said, don't offer anything with building, don't do any of that crap.
Mhm.
But I think they're really useful, so we could more easily get those into a non-credit thing because they don't care. That's kind of where those things can go.
Mhm. So since those don't fill up because they're not required, if I was interested in learning those kind of things, do you have any recommendations?
Well, yeah, not a lot, but you can talk to say outside structures.
Mhm.
Say you're interested in building an outside pergola or gazebo.
Mhm.
You can go to the teacher that's doing the framing class.
Mhm.
If you know who it is and like before the class starts, like say it's a fall class and it's during the summer, you can talk to that teacher and say, hey, could you do a unit or a few days or some time on that project? And they may be able to do it and it would fit in. And actually they like to do that stuff because they get bored with the same old stuff they do. Oh yeah, I'd love to do a pergola, I've done like the school preschool program, which is up on main campus across from the McKinley School.
Mhm.
They wanted a pergola for their preschool kids. And they came to me. A lot of times campus programs come to me and say, would you build this for us? And we just happened to have a roof framing class, and a pergola is sort of a roof on stilts, right?
Yeah.
And so we said, yeah, we'll do it. So we did that it was a summer school class. We did that as our project.
Mhm.
And it worked out great. We did a real practical thing. All the kids would truck up there every week and we built this thing. And we've done a lot of projects on the schools for that. So when they ask for stuff, and we could actually ask them because we know what they used to ask for and haven't had the money to.
Mhm.
Between I don't know if you know the campus between the music department and the drama, there's a big corridor with nothing in it. And somebody came to me a few years ago and said, oh, we'd love some tables and chairs, maybe some umbrellas there. And we just never got around to getting who would pay for it and who would do it. But stuff like that, we could do that. Building furniture is a very, well, that would be an outside structure thing. But, we don't care if it utilizes building skills, we'll do it in a finish class or a framing class so that's what you can do. You can talk to the teachers.
That's interesting. Final question then, if it doesn't seem like it really fits into anything in the main curriculum, like if it's like electrical work, for instance, how would I go about learning more about that?
We have we had an electrical apprenticeship program because in the state of California, you have to pass this certification test. And if you don't pass it or haven't taken it yet, you have to be taking classes in preparation for it at certified places, or you can't work in the electrical field. It's a safety requirement the state sprung on the electricians maybe 10 years ago. And we've had one of my deans way back said, well, that's a pretty necessary thing for the community. So she did all the paperwork and got us certified to do that. So we'd hire first we hired a couple of building inspectors who would do work at night teaching the class. And they would do, first we started with 3 or 4 classes, and then I think we have like 10 now. If you look in the construction, it's under our program. It's not really part of our program, but they had to go somewhere, so they put it under CT. And they're all on the curriculum listing. And they have different things like motors and transformers and electrical, the National Electric Code and electrical mathematics. And that would be great because if you would be interested in that, you could take that class and find out more about something in the electrical field. It wasn't a program that prepared you. It wasn't an apprenticeship program, but and we just rotate those classes. But every once in a while, students would say, "Hey, can we do this thing pretty soon?" And so, blueprint reading for electricians. So I'd tell the instructor, he said, "Yeah, we'll do it next semester." But the problem is we lost one inspector, and then we had another guy. What was Tim? Was he an inspector? No, he's an electrician. He worked for the union. That's right. We had him for a while. Then he retired. Then we had a guy, another electrician, and he got tired of doing it. And then Tim did it from Hawaii, where he retired because we were online with Zoom. But then he got tired of doing it, and we can't find anybody. So we've discontinued it until we can find an electrician. And the stupid thing is the requirements for that, the teaching requirements for that class are actually higher than my construction program for some weird reason. They're in some vocational class category, and they require a bachelor's degree. This one only requires an AA. Yeah. Isn't that weird? And I went to the union. None of those guys who have been teaching for 50 years at the union have BA degrees, and they teach us all the time I'm just going, oh God. So if you know of anybody that's an electrician that's getting toward retirement or just wants to do moonlight a little bit, let me know. But so that's where that is,
That makes sense.
Yeah. But the reason I told you is because maybe you'll come across someone and have the energy to, get it going.
I hope so. I hope I find somebody to be. I was looking at seeing CC's CT program is actually what got me interested in it. I just graduated from UCSB a couple months ago, and I knew wherever I got a job, I wanted to be in a place where there was a decent CT program.
Yeah. Oh, wow.
And so, yeah, I saw those classes, and I was hoping I could learn. So, hopefully, fingers crossed in the future.
Yeah. And the other thing, if it's electrical stuff or plumbing stuff, Jim knows a lot more than I do, because I've been in the field. I was the chair for this program for 13 years, so I stopped being in the field. So I don't know I know they're using PEX now, but I don't know the codes, the recent codes for plumbing and electrical. But Jim and Rodney are still working contractors. So, and Jim teaches the beginning classes, and they have, especially the second one, CT111 has unit 3 weeks on plumbing and electrical and sheetrock and other trades that go with construction. And then he does that non-credit class, and one of those is there's a beginning and an intermediate level, and the beginning is framing, finish, electrical, plumbing, and the advanced is framing, finish, electrical, mathematics. So if any of those things, and they're only 4 weeks apiece, like 4-week electrical, 4-week. So, you could ask him what he's doing in those classes, and they're free. Those could be, those might help you.
Good to know. I'll talk to him about that on Wednesday.
Yeah.
I appreciate it.
Okay. Yeah. And I'll keep my ears open. Yeah, there's not a lot of training, that's why we do what we do. There's not even a carpenters union in town. There was one, and they slowly, slunk away. And I don't know where I think the nearest one's in Oxnard or down there, but yeah. So even if you were interested in that, it's not near, which is crazy, but yeah. But it's, it's the way life is now. It's changing a lot of ways.
We appreciate all the info. Thank you.
Sure, no problem.
Take care.
Okay, Zach. Hey, Austin.
I was just enjoying the conversation.
Yeah.
It's neat that Carol's teaching some classes too.
Yeah. Oh, I meant to announce them. Have they started yet?
No. The next one, the first one starts on the 15th of September, which is.
Oh, okay. I'll announce it next week.
Yeah, it'll be. We come back on the 12th.
Yeah, they can still get in. Yeah. So, yeah. Carol and I went to I don't know if I mentioned it or not, you wouldn't have heard it last week's class. We took a tour of the new landfill uh,
Oh, the
Reclama-
Marburg?
yeah, the reclamation, what do you call it? Building or facility. It's great. I was really impressed. I always go into government things knowing it's going to be really horrible. And this was really good. And they have the educational guys who took us on the tour and developed a program for the schools are excellent. And yeah, it's impressive. It's discouraging because it's only, our landfill's only got about 3 more years left.
The Tahiglis one?
Yeah. So they did all this stuff and it'll really help for 3 years and probably wouldn't even go 3 years. But, and they may be able to do some of this stuff past that, you know, that doesn't go into the landfill like this, like they make compost and wood chips. I don't know why they couldn't keep doing that, but they have to separate out the wet waste. I don't know if they can, you know, we'll see. But it's pretty spectacular, and they give tours. So if you're interested,
I would be interested. Yeah, I read there was an independent article a month or 2 ago about it. But yeah, I'd love to go out. I know they were hiring last year. I think COVID kind of, I don't know, put a halt on that. But yeah, you even need to work at a place like that.
Yeah, it's the setup's really interesting. And the guy, at least the guys who run the education part know their stuff. It was really, really fun talking to him. Yeah, I was quite impressed. That's serious business, you know. I'm glad they're taking it seriously and doing a good job.
Yeah, I know we've run into problems kind of shipping our garbage overseas, right? Wasn't there a whole restructuring with California and China about, you know, recycling different things and plastics?
Well, that's the thing. It's so fluid. Like I was looking at the countries that took recyclables, and you know, Vietnam's doing a lot. China stopped, or at least they told us to take a hike.
Right.
But Vietnam, it's interesting. Vietnam's doing them, but you know, you never know when things are going to dry up. That's the problem. I think we ought to develop more local uses and reuse, and you know, get people to figure out markets, create their own markets, you know. The world is so crazy and explosive right now for all kinds of reasons, right? Geopolitical, pandemic, global warming. I mean, it's just exploding. And depending on anything to survive globally when cultures are going under or will go under, is not a good bet, you know. And so the more you can do, you know, locally, the better in local markets. And it would be good. It would give people jobs and it would save us money. But you know.
All right, sir. Well, I'm gonna go eat dinner.
Okay, good idea. Well, good
I'll
to see you again.
in a couple weeks. Yeah.
Yeah, I'm glad you signed up. That's good.
Yeah. Thanks for squeezing me in.
Sure.
I will. Yeah, I guess. I see only 2 people responded to the journaling thing from last week. I don't know.
Yeah, it takes them a while to get into it. Some will never do it, and that's their choice, you know.
Is that the only homework other than, you know, reading the handouts?
Yeah, occasionally. Well, yeah, the blog is actually more important than the journaling, especially for someone like you. You probably journal anyway, right?
Not as much as I should.
Your dad probably does. But
yes,
the blog.
My sister and I are going to inherit, I'm sure, you know, a garage full of journals and writings and stuff.
Yeah, I know. I don't even know your dad that well, but I can, you know, our generation, we used to do a lot of that.
Yeah.
But the blog is just to get to know people and, you know, talk with your classmates, you know. And there, you know, there may be questions you have that you didn't get to ask me, and you can ask your fellow, you know, your classmates on the blog. So, and I won't, I'll usually put
blog.
It's on the general discussion. Your module has each week has presentation, general discussion, or discussion, I forget what it's called.
Group
assignment.
Discussion. I see.
Group discussion, yeah, assignment, and then journal. So just
Okay.
go to there. I'll put it on probably tomorrow, the topic, because
I see.
I want to make it relevant to what we've done, and I never know what we're going to do. I mean, I have a plan, but
Mhm.
I'll never know what students need.
Do you want me
It would be
to
helpful.
write something from last week, or is
No,
maybe-
no, don't worry about it.
Okay.
And then,
I'll wait for you to put something for this week.
Yeah, and then the assignment, make sure you look at that. It's usually reading. I may ask a few questions along with that. It depends, Depends
Okay.
yeah. So yeah, you're
I feel
doing
like
okay.
I've seen this handout before. I think you might have shown this in the green building. But no, it's
Yeah.
interesting. Like it lists what was the name of the student? He was saying what's the R value of a 2x4.
Yeah, Jack Flores.
Jack Flores.
He's such a weird guy. Sometimes he just doesn't even come to class. And he's been in my classes and I've been pissed at him because he'll never show up. And then other times he's asking a million questions, which I'd rather have. I'd rather have him show up and ask questions. In fact, the questions are good because otherwise you're just listening to me yak, and on a Zoom thing, it's good to have the class interact. It makes it a little more interesting. And these guys ask, you guys all ask good questions. They're really great questions.
Well, I think some of this stuff's interesting. And
I took I told last week's class, you didn't hear, but this consortium of sustainability advisors and companies in the South Coast got together and did this got together and are providing these webinars, and actually they'll come to your school and talk about different topics in building performance. And I went to 7 or 8 webinars all summer, which I hated, but they were actually good. I mean, it took time. You have to sit for a couple hours.
Yeah.
But they were really good, and they published their videos and slideshows. So I'm going to show those. Last week I did the first one, but they're really up to date, which is really great because I was trying to figure out how I was going to upgrade this because I haven't offered it for a couple of years, and bingo, they showed up, and like all the what do you call it? The heating, the
heat pumps?
The heat pump heating and cooling.
I still don't understand exactly how that works. Yeah, so I'm curious about it.
Yeah, so I got a bunch of films on those, and they're really great, and they're going to town with it. It's kind of one of the new alternative technologies. So, but I wouldn't have had that unless I'd done these things. So there's passive house stuff, and I'm critical. I've chatted more than anybody on these things because I'm a teacher, and a lot of the people are designers or real estate people. Real estate people take these stuff to be able to, to sell their house.
And yeah, exactly.
Yeah, and say, oh, look, this has got all this. But because I teach this stuff, I was able to. And one of my students was actually in this consortium that took the green building and the performance, and we did a bunch of stuff with College of the Canyons about this stuff because I belong to a consortium out there. And now she's got a job at this advisory thing. It's really great. I got to see her again. So yeah, that's really nice, that they can get money to do this for free. And they're trying to get builders more aware of this stuff like I'm doing with this class. Because, they got to know it. And I'll find out if we have stretch codes or we have requirements that require energy efficiency. If we don't now, we will eventually.
Yeah, I think Jim did talk about some of that stuff, specifically in the Santa Barbara municipality. Something about, insulating the bays of attics.
Yeah.
That most people do like loose film.
Yeah.
I guess we'll talk about this now, on the floor of the attic, but you don't insulate the rafters of it. And now builders for new construction, and you can go back and do like spray foam for existing structures.
Right.
To more thermally insulate attic space.
Yeah. So, because it's all new, the building departments are pretty flexible. They'll let you trade this for that. But you got this, so don't worry about this, which is really great because nobody really knows how all this stuff works together completely. And so they're real. Plus, they want everyone to do it, so they're not going to be too rigid about it.
Right.
So, But there's some new stuff that's pretty cool.
Mm-hmm.
Okay, guy, go eat. I'll go eat too.
Thanks, sir.
Sounds good. Good talking
See
to
you
you.
in a couple of weeks. Yeah.
All right, will do.
Have a good night.
You too.